the Unit 10 review on exponentials. This is the second video. So we're on number 7. We're on the back of the first page. It says in 2000, the average price of a football ticket for the Minnesota Vikings games was $48.28. During the next 4 years, the price increased an average of 6% each year. Write a model giving the average price P in dollars of a ticket T years after 2000. So we have to remember how the exponential equation is supposed to look. So we need to know you have your initial amount or principal amount. We can call it A or you can call it P. It doesn't really matter what you want to call it. Okay, and then you have 1 plus or minus your rate of increase or decrease here. Okay, and then we're going to be to the power of T or X, and that's representing your time. So let's try to find in this scenario what needs to get plugged in where. So first of all, right there it says increased. So that tells me I'm going to be doing plus. This is exponential growth, right? They tell me that it started as 48.28. So that's what we're starting with, the initial amount. And it says 6% each year. Okay, our R is not actually going to be 6. What's our R going to be? We have to convert the percentage. So what's R going to be? 0.06. To change a percent to a decimal, you move it 2 places. So 0.06 is going to get plugged in for R. And then it said, we're just going to leave T as T. Okay, if you're wanting to know the ticket price in 2015, you would plug in a 15 because it's that many years after 2000. Okay, if you want to know in 2002, you would plug in a 2. But we're going to just keep it as T to write our equation. You keep a variable in your equation. So this is then 48.28. 1 plus 0.06. Now you could leave it like this, or you could go ahead and simplify in those parentheses there. 1 plus 0.06 is 1.06. So that would be the equation that could be used. And like I said, if you wanted to know the price in 2002, you'd plug in a 2 for T because T represents the years since 2000. Okay. Oh, you know what? They did tell us to use P. So instead of Y, I'm just going to make that P because they just told us to use the variable P to represent the price because the price is what we're finding. Okay, so that's the coming up with the equation to model that scenario. For number 8, it asks, or it says, from 1996 to 2001, the number of households that purchased lawn and garden products at home gardening centers increased by about 4.85% each year. In 1996, about 62 million households purchased lawn and garden products. Write a function giving the number of households, H, in millions that purchased lawn and garden products T years after 1996. Okay, so we're going to start with the same base equation. Okay, but this time our percent is 4.85. What does that mean our R will be? As a decimal, what would that be? 0.0485. Okay, remember that decimal is moved 2 places. Okay, if you aren't sure which direction to move your decimal, just remember you're dividing by 100 because percent is out of 100%. So you take your number 4.85 and divide by 100, and that's where this decimal is coming from. Okay, so we've got our R, then our initial number here was 62 million. Now I'm just going to plug in 62 because down here, where like up here they told us the price P in dollars. Here they tell us the number of households H in millions. So the millions is going to be understood. We're not going to put 62 and then all those zeros. We're just going to put 62 and understand that the answer that we get when it comes out is millions. Okay, let's see. I guess we're ready. I think that's everything. So we're going to use H instead of Y because it says to use H. Okay, our initial amount is 62. This is increasing, so again, it's addition. It's a plus here, 0.0485. And then T is our variable that we're going to keep in the equation. So we could simplify that by adding what's in the parentheses to 1.0485. So that's the equation that could be used to determine the number of households purchasing lawn or garden equipment T years after 1996. So if it was in 2000, we'd be plugging in a 4 because that would be 4 years after 1996. You'll feel okay about setting those up? Okay, on the test, you are going to be asked to set equations up or which of these equations represents the scenario. Okay, you're not actually going to have to plug in and calculate answers for them, but you have to be able to set them up and or match which equation is accurately written. Okay, so remember, if that base value is above 1, it's exponential growth. Okay, these were both growth, they were both increasing. Okay, if you had a situation that said decreased, this should be 1 minus, and you would end up with a negative number, or excuse me, not a negative number, but a number less than 1, because you would do 1 minus the rate. Okay, so when you're looking at your answer choices, sometimes you can just eliminate based on the fact that the base is above 1 or below 1. Okay, and you know it should be increasing or decreasing based on the scenario given. Okay, so be careful with those. Okay, let's see. Actually, the bell's going to ring here in a minute, so I'm going to stop this video here and just have it over those 2 word problems, and then I'll have another video over the solving problems beneath it.